what's up, everybody? This is Mr. Juzo. We're going to go ahead and do problem number 6, which is expand using the binomial theorem or Pascal's triangle. This binomial right here, x plus 2y to the 5th power. So, remember, you could use and choose R for this to find each of the coefficients, but I'm just going to go ahead and use Pascal's triangle because it seems like it's a lot easier or maybe less work. Although you could use your calculator for and choose R, but here we go. So let's derive the triangle real quick. So remember, the triangle starts with 1 at the top, and we always have 1s on the edges, right? So there's 1, 1. And now my third column will be a 1 on the outside, and remember that the middle term comes from the summation of these two right here. So these two added together gives you your 2. So remember, this is our x plus y to the 0 power. Okay, because anything to the 0 power is 1, so there it is. This one is x plus y to the 1st power, and then you get the idea, x plus y to the 2nd, 3rd, 4th, so let's just go ahead and derive it quicker now. To the 2nd, and so here we go. 1 plus 2 is 3, 2 plus 1 is 3, and then you end with 1s, and then at these two, 6, and 4, and then 1s right there. So that's x plus y to the 3rd, x plus y to the 4th, and then since this is to the 5th power, we got to make sure we go all the way down to the power of 5. So this is going to be 5, 10, 10, 5, 1. So now, this row right here of Pascal's triangle is what we're going to use as our coefficients for this binomial when we expand it. So let's go ahead and expand it and see what we come up with. So here we go. Now, remember that your exponent is 5. So whatever your exponent is, you always have one more term when you go ahead and expand it. So here we go. We have 1, 2, 3. Oh, man. So let me just get rid of Pascal's triangle over here so that we can actually work out the problem. But the cool thing is that the column that we need is this one anyways. So 1, 2, 3, 4, 5, and 6 terms. Now, since all of these are positive, then it's cool because that means that all of these are going to be positive in this case, right? So we're good with that. So now let's go ahead and write in our coefficients, and then we're going to go ahead and follow our binomial theorem, or actually the pattern that we discussed in class. So let's see. So we know the coefficient for the first one is 1. Coefficient for the second one is right here. 5, 10, 10, 5, and 1. Those are your coefficients. That's not the number you're going to end up with depending on what you have here. So here we go. Now, remember the term on the left, in this case, is our x. It's just x all alone, all by itself. So all we got to do is, starting from the exponent on the highest power, which in this case is 5, we're going to go ahead and go in descending order all the way down. So here we go. The first one is x to the 5th power. Then we go down to x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and then x to the 0, but remember that simply is just 1. And then for the 2y, we do the same thing, but now we're going to actually, if you start from here, you can follow the exact same pattern, but go backwards. So this is 2y, so it's going to be 2y to the 5th. Now be very careful with this. This is, from the classes I've graded so far, there was an issue with this. You guys were raising only the y to the 5th power, not the 2. So you got to raise the whole thing to the 5th power. Notice that this is 2y. So what you're raising here to that power is the whole thing, the 2y, not just the 2. I mean, not just the y. It's the whole term. So this is going to be 2y to the 4th, 2y to the 3rd, 2y to the 2nd, 2y to the 1st, and last but not least, 2y to the 0 power. But remember, that's just simply 1. So now what we're going to do is simplify this, and you're done. So let's see. This is going to be 1 times x to the 5th, which is x to the 5th, plus 2y to the 1st power times x to the 4th times 5. Well, 5 times 2 is 10. X to the 4th, y, plus 2 squared is 4, times 10 is going to be 40. But 40 what? Well, 40x to the 3rd, and remember this was 2y squared. So the y is to the second power. So we continue on down, and we end up with 2 to the, oh no, we're here. So 2y to the third power. 2y to the third power is going to give you 2 times 2 times 2, which is 8y to the third, times 10. That's going to give us 80. 80x squared, but then it's going to be y to the third, plus, now 2 to the fourth. So if 2 to the third was 8, then 2 to the fourth must be just one more 2, right? So 16 times 5, y to the fourth. So 16 times 5. Oh my God, I should know that off the top of my head, but I don't. Oh, 80. Cool. So 80x y to the fourth, and then last but not least is going to be, well, this is a 1, so this is 2y to the fifth power, so 2 to the fifth power, well, 2 to the fourth was 16, so 2 to the 5, just one more 2, is going to be 32, so it's going to be 32y to the fifth. And that right there is, this is already expanded. Now, we are very fortunate to have the binomial theorem, to have Pascal's triangle, because could you imagine doing this by just FOIL and, okay, it would take a while. So let's go ahead and do this one now. This one is very similar to the one we just did, except that now as the exponent is 6. If the exponent is 6, that means we're going to have how many terms? One more than the exponent, so 7. So, here we go. Now, in this problem, notice that these are, normally we see z minus 1, normally have the variable in the front. Now, it doesn't really matter, but just for family, to be a little, so that it looks a little more familiar, I'm just going to go ahead and just flip them around, and just notice my 1 is negative, my 1's still negative, my z is positive, it's still positive, it's still to the 6th power, so these, this and this are still the exact same thing. So I'm just going to go ahead and flip it around just so that, like I said, it looks a little more familiar when the variable is in the front, but in the end the answer is going to be the same. If you keep it this way, it's probably going to look a little bit like backwards, but you'll see when we're done. So first thing we're going to come up with is, let's just list our terms. Now, remember that this is a minus. If we have a minus there, the signs are going to happen to actually alternate. This one's going to be positive, this one's going to be negative. Remember that it's going to be negative because the power is odd. And Mr. McCaffrey discussed that in one of the videos that he did during the lessons. And there it is. So now all we need to do is come up with the coefficients. So I'm just going to continue with my old Pascal's triangle because, oh yes. Thank you, Mr. McCaffrey. It happens, guys, it happens. So here we go. Now I'm going to continue with Pascal's triangle right here. One more row, because notice that this is x to the 6th power. This one was where we left off right here, was x to the 5th. So if we go one more row down, that will give us the coefficients we need for that. So let's see, 1, this is going to be 6, this is going to be 15, 20, 15, 6, and 1. So these are now my coefficients that I'm using for this binomial. So here we go. Let's go ahead and get them done. So it's going to be 1, 6, 15, 20, 15, 6, and 1. So those are the coefficients. I got them from Pascal's triangle, but remember, if you want, you can go ahead and just do n choose r, n being, remember, the exponent, r being whichever term you're looking for. But like I said, it's a matter of preference, I guess. So here we go. Now let's list the terms, and we'll be done. So remember, here's my z, starting from your highest power, go in descending order. 4, z3, z to the second, z to the first, and z to the 0, but remember this is just a 1 right there. And now we're going to go with the negative, with the 1, since we already did the signs in there. It's going to be 1 to the 6th, 1 to the 5th, and you're already thinking, well, why is he writing them? Because they're 1 anyway, so it's not, it shouldn't make a difference. And you're right, it's not going to make a difference because they're all 1s. And 1 to the 0, which is 1. So the final answer, we just have to simplify and we'll be done. So the one on the left is going to be z to the 6th. This one's going to be 1 times 6. Obviously, it's just 6 z to the 5th. This one's going to be 15 plus 15 z to the 4th. This one over here, minus 20z to the third plus 15z squared minus 6z plus 1. And that right there is the expansion of this specific binomial.